Good afternoon, everybody. Respected chairman and all organizers, I would like to thank you because my talk was at the end of this session, but you prepondered my talk because of I'm in hurry. I'm going outside. The talk is regarding. It is not my research work. I have not done any research on this particular topic, but it is my observation, general observation during my paleoclimatic studies and paleoseismic studies. I come to know several other things that what are the keen acumen of the Dholavira people or Indus Valley people, particularly for the geological science as well as the hydrogeological science. So it is regarding the hydrogeological acumen of the Dholavira people or Indus Valley civilizations. We know all this, the Dholavira, Indus Valley is one of the largest civilization in all this other Egypt, Egypt, Euphrates, Tigris, Mesopotamia, Indus and China. This is one of the largest and the most widely developed with all technologies and keen acumen of the science. This is a timeline of the comparative studies of the Indus, China, Mesopotamia, and Egypt. I'm not going into the much detail of these particular things, but in the particularly Indus civilizations, it is all 7 different stages, which basically in Dholavira we got these 7 stages, right from the early Harappan to the late Harappan. So it is; these are the already published data I have put here. The mature one, Harappan phase 3A, 3B, 3C, where most of the developments, the archaeological developments and hydrogeological development occurred, that we will see in some of the photographs. So they had a keen acumen of the using the natural resources, because even in the early sessions we have got the knowledge that they had good understanding of the metallurgies and the geology from where they got the resources. Like they got drill bits, agates. Where do they get these agates and some of the metallic elements, the minerals, how to smelt them? It's all the technology they did earlier, so 2, 3, 4,000, 3,300 years BC till the end of the vanishing of this particular Indus Valley civilization. So I'm going to talk a little about how this civilization vanished. What are different factors, geological factors or climatic factors or some natural calamities. So they had a very good understanding of all different science, marine science, geological science. See the earliest form of sanitary engineering. So this is a kind of things which I have borrowed from others regarding the Mohenjo-Daro's photographs. It is not the Dholavira's photographs, but it will be followed by the Dholavira photographs. So that is the first known toilets and running water in residential buildings in the world. It's first of its kind in the world, which 4.5 thousand years back. So by 25 BC, highly developed drainage systems where watersheds from each house flowed into the main drain. So they had a very good understanding of the drainage systems, which we now follow in our day-to-day practices. The ancient Indus systems of sewerage and drainage that was developed and used in cities throughout the Indus Empire were for more advanced than any found in contemporary urban cities, sites in the Middle East, and even more efficient than those in some areas in modern Pakistan and India. And basically we have adopted the same thing in today's our drainage and even water harvesting also, we have adopted the same thing. So this is also the Mohenjo-Daro and Harappan, but we are now going to the what are different evidences of the hydrogeological acumen of these people. We'll see these are all the same things, town plannings and central sewage, but more or less we should understand based on these developments of their sense of hydrogeological sense. Why they had to do this? Because there was strong crisis of water. In all 5,000 years from now, I mean 3.3 Ka BC, they used to live in a kind of a scarcity of water. There was a paleoclimate record says this was a major period, some few 100 years of the wet period was there, but more or less the monsoon pattern slowly and slowly it changed, and the tectonic effects of the landscape that also changed. So tectonic effects of the landscape has changed the river systems. The course of the major rivers, they shifted to the more western part, while that is why the people started migrating. But another factor of migrations of the people, that the monsoon also changed, monsoon pattern, and that is why these Dholavira people slowly and slowly migrated to the more fertile areas in the Ganges, and that is why the entire civilization vanished. And this is what I just mentioned, that monsoon and population shift. So we know that after that 1.5 Ka BC, the people started shifting to the more and more east to the Ganga Valley because of the mostly the water availability, and the major river courses abandoned, and so that is why the particularly this civilization vanished. Now we come to the core part of this particular observations, that which is objective of this study or observation. It is not my hardcore research. To establish the hydrogeological acumen of the Dholavira people using the existing archaeological structures and establish the paleoclimatic conditions of the respective period. This particular paleoclimatic perspective, we did work on the fringe part of the Dholavira. There are some quaternary deposits which is of 5.5 Ka for BP. So these deposits we have analyzed based on the grain size analysis, but then we also studied the geochemistry of this particular things, from where these sediments came. So what kind of particular system, fluvial system or the estuarine system existed, and then how did they vanish, these estuarine systems or intertidal system. So we have got these results, and recently we are going to publish it in the one of the journals, international journals. So this is what the Dholavira is, particularly at these locations. Okay, so I don't want to there's no need to explain the topography, a very unique kind of run topography, and they are actually the sites of hundreds of different archaeological sites. So it is all known to everybody, but how did they vanish? That is a big questions. The climate, whether climate has played a major role or whether the tectonics has played. But as per our geological studies, climate and tectonics both have played major, because Kutch is a seismically very, very active region. So it is slowly and slowly uplifting landscape. So when you uplift the landscape, if there is any system, estuarine systems, and they will slowly and slowly vanish. And if water level is rising, in last 5,000 years, water level is, I'm talking about the eustatic sea level, it is changing, and we are in the rising sea level. So that is also played major roles. How rising sea level changes has transgressed the sediments, transgressed the run of Kutch, and how did they played a major role in vanishing the major river systems which coexisted with Indus and the Saraswati, which we are talking about since long last several years, whether this system existed or not. But there were some systems which is now vanished because of the tectonics and climatic parts. This is the general geological maps by Biswas and Deshpande. But this is why I give this map here, because to understand the geology, which actually Dholavira people also learn. Now, these people also have a very keen observations about the topography and the slope, and because they had a good understanding of the slope, they could develop several reservoirs and several dams. We'll see in some of the photographs. This is where we studied the quaternary deposits. These are trunky bed, and these are the fringing quaternary deposits, which we found is very young. I mean, it is equivalent to the Dholavira time, 5000 BP. So, if I want to see the older landscape where Dholavira people were existed, I have to remove those deposits. So, if I remove those quaternary deposits, what would be the situations? This is a very interesting fact. We have to go back. This is where we Dholavira exists, and you can see the Manhar and Mansar, two small nala. Even so, they had a very keen acumen how to preserve a very small drop of water. So, using a small nala during the rainy season, how do they basically dam the water? And they had several 16 reservoirs surrounding the structure side. So, these 16 reservoirs, how meticulously they studied the reservoir and the rock systems, so that one reservoir got filled up and then it is spilled to the other reservoir, reservoirs. And these reservoirs basically recharge the wells. Basically, it is in the royal upper house, upper towns where the royals basically used to live. So, where these deep wells, they used to be recharged by these lower reservoirs. We'll see these reservoirs. This is all I borrowed from the books. You can see these are reservoir. This is a dam. This is a dam. There are several dams they prepared. You can see right in the sites how meticulously they put the dam, and they block the river channels. And this particularly damming of the rivers, this water will go to this reservoir, and then it goes to this reservoir, and surrounding all reservoirs, slowly, if the water is excess, they can spill to the other reservoirs. So in the last reservoir, very interesting is that last reservoir, they had a geological fault, so that if any excess water comes to the last reservoir, the water will be lost. From the fault, the water is lost. So I'll show you some of the things. This is all, I think everybody has worked on Dholavira. Many of you have worked in Dholavira, but this is one of the largest reservoir with 31 stairs for general purpose, especially for royal families. And you see how big it is. And now, if it is a full length, then it can last for several months for the royal family. Say the rainwater harvesting system, which have very strong acumen of the rainwater harvesting.
Dr. Thakkar, please, yes. Dr. Thakkar, you will have to wind up it.
Okay. So you can see how they had a harvesting system. The rainwater from the upper town, they overflowed to some of the tanks, and they used to use for the bathing purpose. They used to use for the general purpose for the potable water also. So these are all. This is the well. This is some 20 meters deep well, and they used to use for the drinking water purpose. But around the year, these used to be recharged by the surrounding reservoirs. So this is a very scientific development of these people, where you see the reservoirs, they are lined by the mud and clay things. So each reservoir was interconnected by the waterways. These are all rock cut reservoirs, and these rocks are sandstones, so they are porous. So they used to recharge the downstream irrigation tanks. So they have very good understanding of the geology and hydrogeology. This is a fault in the last reservoir. So I just talked about this thing. The upper town has a very significant structures, rainwater. We all talk about these things. These are fringing deposits which we dated. These fringe deposits of the Dholavira, but we have to remove this if we want to see the Dholavira landscape. Okay, but for This purpose, we have analyzed them. It's a beach and sand dune facies. They are all dated, and it's 2.3 Ka to 9. It's a Banjara bed, just opposite to the Doravilla, and 5.2 Ka to 5,500 years. There is a chronology of the Dolavira site, all quaternary deposits. These all we have found the very paleo channels. So many people have found the paleo channels which used to flow across the run, and they used to give the sweet waters. We analyzed these particular sediments, which are now geochemically analyzed. They are all part of the Himalayan sediments. Recently, just 3 days back, we have analyzed, and they are all. I think I skipped this part, Holocene climate change, and that is all. The Indus Valley civilization vanished. Okay. So this is all collapse theory, and this conclusion. I am coming to the conclusion because people are hurry. Okay, looking to the great regression system in all related structures, Dolavira is considered as the most advanced urban sites of that time, and a well-planned sewerage system indicates higher energy engineering skills. Such skills need climatic adversities. Hence, it is said that climate was not much congruent in the northern Kutch or Western India, so that they did not miss a single drop of water. That's it.